Hello everyone! Today we're going to learn how to solve quadratic equations by using the quadratic formula. So a quadratic equation written in standard form can be solved by using the quadratic formula. Remember that standard form of a quadratic equation is ax squared plus bx plus c equals 0. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully this part right here looks a little familiar to you. B squared minus 4ac, the part underneath the square root symbol, is the discriminant. And so we're going to be using that to help us as we're going through and using the quadratic formula. So if we look at this first example, it says solve each quadratic equation using the quadratic formula. So on example 1, I have x squared plus 6x plus 8 equals 0. Step 1 is to identify a, b, and c. So I can see that a is 1 because that's the coefficient of x squared. B is 6 because that is the coefficient of x. And c is 8 because 8 is the constant. So that's step 1. Step 2 is to plug into the formula. And I have the formula listed out for you here. So I'm going to have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Step 3 is to calculate the discriminant. So remember, the discriminant is the number underneath the square root symbol. So I'm going to go ahead and rewrite this. So I'll have x equals negative 6 plus or minus the square root. And then I'm going to calculate that discriminant here in a second. And then 2 times 1 is 2. So I'm going to go ahead and calculate that discriminant, that number that is underneath the square root symbol. Let's see what we get. So 6 squared is 36. Negative 4 times 1 is negative 4. Times 8 is negative 32. So 36 minus 32 is 4. So I've calculated the discriminant. The discriminant is 4. Well, what do we know about a positive discriminant? A positive discriminant means that we are going to have 2 real solutions. Excuse me. So because my discriminant is 4, that means in the end I should get 2 real solutions, meaning I should have 2 x-intercepts. Step 3. Simplify the square root if possible. So let's see. The square root of 4. Can I simplify that? Yeah, the square root of 4 is 2. So I'm going to have x equals negative 6 plus or minus 2 divided by 2. Step 5 is to simplify. Now, there's going to be a couple different ways to simplify as we look at the different types of problems that we're going to get. But when we look at this one, I can see that negative 6 and 2 are like terms. So I can go ahead and say, all right, if I know that these are like terms, I can separate this into 2 different problems. Those 2 different expressions are going to be negative 6 plus 2 divided by 2 and negative 6 minus 2 divided by 2. So let me show you where I got those. This plus sign here is how I got negative 6 plus 2. And let's use a different color. And this minus sign here is how I got negative 6 minus 2. So I have 1 for the plus sign and 1 for the minus sign. So now I can simplify each of these. Negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. Negative 6 minus 2 is negative 8. Negative 8 divided by 2 is negative 4. So I have two real solutions, which is what we said would happen when we found our discriminant right here. And those two real solutions are negative 2 and negative 4. Because these answers are rational, that means this problem was factorable, and you could have also solved by factoring. The wonderful thing about the quadratic formula is that this method will always work. None of the other methods work every single time, or they might work, like completing the square can work almost all the time, but it might be a little bit messy or not as pretty as using the quadratic formula. So that is why we like the quadratic formula, is because this method works no matter what type of quadratic you have. So when you're getting stuck, when you're looking this over, all you need to do is come back and look at these 5 steps. Step 1 is to identify A, B, and C. Step 2 is to plug into the quadratic formula. Step 3 is to calculate the discriminant. Step 4 is to simplify the square root if possible. And step 5 is to simplify. So let's try that on another example. If you look at the next page, I have the steps listed out for you here. And I have the quadratic equation also available for you over here. So let's see how far we can get on example 2. So it needs to be in standard form, and 5x squared plus 4x minus 3 is in standard form. So I can begin by identifying A, B, and C. In this problem, A is 5, B is 4, and C is negative 3. So now I am going to plug into the quadratic formula. So I'm going to have x equals. And I'm just going to go ahead and put my parentheses in there for myself. If you would just rather go ahead and plug in the numbers without doing this, you 100% can. So I'm going to have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's step 2. Step 3 is to calculate the discriminant. So I want to calculate this number inside of the square root symbol. So I'm going to have negative 4 plus or minus the square root of whatever I get for my discriminant. And then 2 times 5 is 10. So let's go ahead and calculate that discriminant. So when I do that, I'm going to do this in my calculator. Let's see. So I'm going to have 16 plus 60 is 76. Step 4 is to simplify the square root if possible. So let's see. I need to simplify the square root of 76. 76 is not a perfect square. So to simplify this, I'm going to have to use the birthday cake method. The smallest prime number that goes into 76 is 2. That goes in, whoops, what did I do here? Let me get my pen back. 38 times. There we go. 2 goes into 38 19 times. 19 goes into 19 one time. When you get to 1, you're done. That's the candle to your cake. So because it's a square root, that means I'm looking for pairs of numbers to leave the square root symbol. 19 doesn't have a pair, so 19 stays inside the square root symbol. So right now, with my quadratic formula, I have -4 plus or minus 2 square roots of 19 divided by 10. My next step is step 5, which is to simplify. Well, when I look at this problem, -4 and 2 square roots of 19 are not like terms. So I can't add and subtract them together like how we did in example 1. But what I do notice is that -4, 2, and 10 are all divisible by 2. So what I can do is I can reduce this by dividing by 2. -4 divided by 2 is -2. 2 divided by 2 is 1. And 10 divided by 2 is 5. So my answer is -2 plus or minus 1 square root of 19 over 5. Remember, this is 2 answers. The first answer is -2 plus the square root of 19 over 5. And the second answer is -2 minus the square root of 19 over 5. So if it helps you visually to see that this is 2 answers, then you can separate them out. Or you can just write the answer as one expression using the plus or minus symbol. However you want to do it, they represent the same thing. Let's try example 3. So on example 3, when I look at this problem, I can see that this is in standard form, and because it's in standard form, I can identify A, B, and C. Here A is 4, B is 8, and my constant C is 8. So I'm going to go ahead and plug into the quadratic formula. So I'll have -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to go ahead and calculate the discriminant. And I remember the discriminant is the number inside or underneath the radical. So that's what I'm going to calculate. 2 times 4 is 8. All right, so let me grab my calculator. And when I do that, I get -64. Our next step is to see if we can simplify our square root. So I have the square root of -64. My discriminant is a negative number. Well, what did we learn about the discriminant when it's negative? When the discriminant is a negative number, this is when you have no real solution. And that is your answer. If you try to do the square root of -64 in your calculator, you're going to get an error. And that is because the square root of -64 is actually an imaginary number. And you'll learn more about imaginary numbers in another course. So whenever you calculate your discriminant and it is negative, there's nothing else you need to do except to say the answer is no real solution. What I would like you to do is pause this video and see how far you can get on this try this problem. On the try this problem, it is in standard form, so I can identify A, B, and C. Here, A is -5, B is 12, and C is 128. So I'm going to go ahead and plug in to the quadratic formula. And so I'm going to have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alright, so let's see. I'm going to have x equals -12 plus or minus the square root of whatever I get for my discriminant divided by -10. So now I'm going to use my calculator and I'm going to calculate that discriminant. And when I do that, I get 2,704. And I'm pretty sure this is a perfect square, so I'm going to check in my calculator, and it is. If 2,704 was not a perfect square, then I would need to do the birthday cake method. But luckily for us, it is a perfect square. The square root of 2,704 is 52. So now we're on step 5, which is simplify. When I look at -12 and 52, I can see that these are like terms. And because these are like terms, I can go ahead and continue this problem. And so I'm actually going to have two equations. I'm going to have -12 plus 52 over -10, and I'm going to have -12 minus 52 over -10. I have two equations because I have one for the plus sign and I have one for the minus sign. So now I can go ahead and solve each of these equations. -12 plus 52 is 40. 40 divided by -10 is -4. -12 minus 52 is -64. -64 divided by -10, you could say 6.4. I prefer to use fractions. So I'm going to simplify this by dividing each of these by 2, and that's going to give me 32 over 5. So my solutions are -4 and 32/5. Let's go ahead and look at example 4, which is our last example. The first thing that I notice with example 4 is that -2x squared plus 17 equals 6 is not in standard form. And that's because it must equal 0. And so to make it equal 0, I'm going to subtract 6 on both sides. Whoops. And when I do that, I get -2x squared plus 11 is equal to 0. Now I'm ready to identify A, B, and C. In this problem, A is -2. B is 0 because I do not have an x term. And C is 11. So I can go ahead and plug into my quadratic formula and get x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, so I'm going to have x equals negative 0 is the same thing as 0. And then for my discriminant, I'm going to get 88. And then 2 times negative 2 is negative 4. Well, let's think about this. 0 plus or minus anything is not anything. Meaning 0 plus 2 is 2. 0 plus 7 is 7. 0 minus 8 is negative 8. So I can go ahead and get rid of the 0 because it's not going to change anything. So I'm going to have plus or minus the square root of 88 over negative 4. My next step is to simplify the square root of 88. And to do that, I'm going to use the birthday cake method. The smallest prime number that goes into 88 is 2. It goes in 44 times. The smallest prime number that goes into 44 is 2. It goes in 22 times. The smallest prime number that goes into 22 is 2. It goes in 11 times. The smallest prime number that goes into 11 is 11. 11 goes into itself 1 time. When you get to 1, you're done. That's the candle to your cake. So I'm looking for pairs of numbers to be able to leave the square root symbol. And so the 2's can leave. This 2 doesn't have a pair, and neither does this 11. So I multiply 2 by 11. So that gives me 2 square roots of 22. So what that means is that the square root of 88 simplifies to 2 square roots of 22. Now we're on step 5. And we want to simplify if possible. Well, I can reduce 2 and negative 4. And I can reduce them by dividing by 2. Oops, sorry. And so when I do that, 2 divided by 2 is 1. And negative 4 divided by 2 is negative 2. So your answer is plus or minus the square root of 22 over negative 2.